Today what we want to look at is finding rational zeros of a polynomial function. So I give you guys a little bit of an example here. I have a polynomial function f of x equals 64x cubed plus 120x squared minus 34x minus 105. And I know after doing some work we'll find out that these are my zeros of this function. And what I want to do is notice that the numerators of these is negative 3 and negative 5 and 7, which are factors of this negative 105, or the constant term. Also notice that the denominators of 2, 4, and 8 are all factors of the leading coefficient. So based off this, people have noticed that in order to find the rational zeros of a polynomial function, there's a good chance that it's going to be a fraction of some sort in which it's going to be a factor of the constant term over the factor of the leading coefficient. So let's look at an example, okay? And what I have written down is I've written down some steps for you. So I have this polynomial function, x cubed plus 2x squared minus 11x minus 12. And what I want to do is I want to find the zeros of this function, but in order to do that, first I have to find out what the rational zeros are. Remember, rational represents a fraction. Okay? So the first thing I do is I figure out the factors of the constant term and factors of the leading coefficient. So negative 12 is my constant term. Okay? And I figure out that 1, 2, 3, 4, 6, and 12 are all factors of negative 12. Okay? And then I figure out all the factors of my leading coefficient, which is 1 in this case. So what are my factors? Just 1. That's the first thing I do. Well, the second thing I do is take all the factors of the constant term over the leading coefficient. So what I know is that if it's a 0, I know that it's going to be something that I can plug into this equation, and if it's a factor based off the factors theorem, that I know that it's supposed to equal 0. So I take the 1 over the 1. I take negative 1 over 1. So that's how I get those two. I take 2 over 1, negative 2 over 1. That's how I get those two. 3 over 1, negative 3 over 1. And I keep on going on and on. So in this case, there could be possibly 12 zeros possible chances. So what is the next thing I do? Well, the next thing I do is I actually substitute the potential zeros into the equation until I find a factor. So when I plugged 1 into this function here, I found out that I got negative 20. And then when I plugged negative 1 into this function, I got 0. So that means that negative 1, or x plus 1, goes into this quantity perfectly. Okay? I'm not going to go on because I already have identified 1, 0. And what I'm going to do next is actually, once I found that 0, I want to use synthetic division with that 0. So because x plus 1 is a factor, I know that x plus 1 goes into this quantity. I'm going to plug negative 1 into this quantity. So I have 1, 2, negative 11, and negative 12. Bring down the 1. I have negative 1. I have 1, negative 1, negative 12, positive 12, 0. So I know right now that if I were to take x plus 1 and multiply it by x squared plus 1x minus 12, I would get this quantity. So I'm not done. I want to find out if there's any other zeros. So instead of going back to the beginning, I have a smaller quantity right now. I have x squared plus 1x minus 12. And I want to check to see what? I want to check to see, with that new polynomial, check to see if it is factorable. If it is, factor it. If not, check other possible zero combinations. So I look at this. Is this factorable? Well, I think it turns out to be x plus 4 x minus 3. This is factorable. Okay? So what happens is now I know that the fully factored form of this is x plus 4, x minus 3, x plus 1. So what are my zeros? I know x will equal negative 4, positive 3, and negative 1. Those are all of my zeros. So let's look at another one. It's slightly more complicated. It's 10x to the 4th minus 3x squared minus 29x squared plus 5x plus 12. I'm going to do exactly the same thing I did. First thing I'm going to do is figure out all the factors of the constant term. In this case, my factors are still, the constant term is 12. And in this case, 10 are the 10 is my leading coefficient, so I write down all those possible factors. The second step is to take all the factors of the constant over the leading coefficient. So like I'm taking 1 over the 1, 1 over the 2, 1 over the 5, 1 over 10. Then I'm going to do the same thing with 2. 2 over 1, 2 over 2. I don't do 2 over 2 because I already know that's going to be 1. 2 over 5 and 2 over 10 is 1/5, so I don't have to write that down. So I'm going to try to reduce repetition. Like I'm simplifying the fractions as I go through it in my head. So in this case, I have a lot of possible zeros. I got 8, 16, 24, and 32. So those are a lot of possibilities. Okay? What do I do next? Step 3 is to plug in these zeros into this equation, or these possible zeros into this polynomial until I actually do get a 0. So I plug in 1, negative 1, 1/2, negative 1/2, 1/5, negative 1/5, 1/10, negative 1/10, 2, negative 2, 2/5, negative 2/5, 3, negative 3, and 3/2. And I do not get a 0 until, happy, happy, joy, joy, I get one at negative 3/2. Okay, so that's a 0. So what does that mean I can do? Well, I can use synthetic division with this, okay? Because what I know is that x plus 3/2 goes into this quantity perfectly. So I'm going to plug negative 3/2 into this quantity. So I got 10, negative 3, negative 29, positive 5, and positive 12. So we're bringing down the 10. 10 times negative 3/2 is negative 15. Negative 3 plus negative 15 is negative 18. Negative 18 times negative 3/2 is positive 27. I get a negative 2. Then I get a positive 3, which gets me a positive 8. And then I get a negative 12, which is 0. So this means right now that this is going to be 10x cubed minus 18x squared minus 2x plus 8. If I multiply this by x plus 3/2, I would get that quantity right there. Okay? So what do I do next? Well, what did we do? We said check this with the new polynomial, which we got 10x cubed minus 18x squared minus 2x plus 8. I want to check to see if it's factorable. If it is, factor it. If not, check to see if other possible 0 combinations. Well, the only way that I know how to factor this is by grouping. Well, and then I know negative 2. Actually, I know that 2x squared goes into that. So I got 2x squared times 5x minus 9. And then minus 2 times x minus 4. So, nope. Nope, it is not factorable. Okay? So what do? Well, now I got to check to see if other possible zeros go into it. So, these are all the zeros we came up with at the beginning. All right? I'm not going to have to plug them all in. All right? Because what's happening is my constant term is 8, and my leading coefficient of this is 10. All right. So I know it's going to be plus or minus 1, plus or minus 2, plus or minus 4, okay? And then it's plus or minus 8. Now, if I don't see it here, if I don't see 1, 2, 4, or 8, I can cancel those out, okay? Like I know 3/5. 5 is a factor of 10, but 3 is not a factor of 8. So I can cancel that one out and that one. 3 is not a factor of 8, so I can cancel this one out. And that doesn't work, okay? 6 doesn't work. -6 doesn't work. 6 doesn't work. These don't work because they aren't factors of 8, okay? So these all don't work. So I only know that it could be 4, -4, 4/5, or -4/5. Okay? And all I have to do is plug those into this equation. So I'm going to plug 4 into this equation. And when I plugged 4 into this equation, I got 352. So I know that that is not a 0. I plug -4 into this equation, I get -912. Okay, so I know that's not a 0. I plug 4/5 in, I get 0. Okay, so what I'm going to do is plug 4/5 into this equation right here. So I'm plugging 4/5 into 10, -18, -2, and +8. Okay? So when I do that, I get 10, -10, +8 gets me -10. And then I get -8, which gets me -10. And then I get -8, and then I get 0. Okay? So right now, I have 10x squared minus 10x minus 10. Okay? So I know that if I multiply this by x minus 4/5, and if I multiply this by x plus 3/2, I would get this quantity right here. Okay? So I know right now that x equals -3/2 and 4/5. I want to find out what the other zeros are. Okay? So what I'm going to do is this is not factorable, so I'm going to use the quadratic formula. So so a is 10, b is -10, and c is -10. Okay? So x equals negative of -10 plus or minus -10 squared minus 4 times 10 times -10. All over 2 times 10. Okay? And when I do that, I get 10 plus or minus 100 plus 400 over 20. Okay, which simplifies. I get 10 plus or minus square root of 500 over 20, which turns out to be x equals 1 plus or minus square root of 5 over 2. So those are I have 2 zeros there, and then I have -3/2 and +4/5 to be my 0. What I want you guys to do is look at this next question, to try this one and do that one, and I will see you tomorrow.